Title of your next set of Cornell notes is Solving Linear Systems by Elimination, Adding and Subtracting. Your essential question: how do you solve linear systems by eliminating a variable? The key thing with linear systems by elimination using addition and subtracting is to make sure that you are organized. The more organized you are, the easier you'll be able to understand the steps so that you are successful with solving linear systems by elimination. This is the third method that we've learned. We first talked about solving linear systems by graphing. Then we did solving linear systems by substitution. Now the third method is solving linear systems by elimination. Alright, so our next subtitle, you're going to use addition to eliminate a variable. Here's example 1. We have our first equation, 2x plus 3y equals 11. And our second equation, negative 2x plus 5y equals 13. And if you notice with both of these equations, they are in standard form. You have your x and your y variable on the left side of the equal sign, and then you have your constant on the right side. Using the method of solving linear systems elimination, using this method allows you to solve systems without having to rewrite the equation, unlike when we were working with solving linear systems by substitution. With this method, if it's already in standard form, you can go ahead on and eliminate or solve the system without having to do too much additional work. So step 1, you have to add the equations. And here we know that we can add because we have inverse operations. We have positive 2x minus 2x. Since those are opposite of each other, those are simply just going to go away. Then we're going to end up with, if we add 3y and 5y, we'll get 8y equals 24. And then we can solve for y, divide both sides by 8. Y will give you a value of 3. And as you can see, step 2, we went on and prematurely solved for y, but I repeated the process for you. Step 3, you're going to substitute 3 for y in either of the equations. Just like when we solve linear systems by substitution, once we receive the variable, we determine what the value of x was, or we determine the value of y, we then substituted that value into the other equation. Very similar here. You have to substitute what we know is the value of y, which is 3, into either of the equations. In this case, you can choose either one. It'll be about the same amount of work no matter which equation you use. In this case, I just happened to use the first one. So we have 2x plus 3y equals 11. Substitute y for 3. And once we simplify, we can solve for x, which has a value of 1. And our solution is 1, 3. And just like I said before, we are imperfect. Sometimes we make mistakes. So we need to check and verify that what we have is correct. So step 4 is to check. You're going to substitute the values for x and y into both equations. And here on this side, I substituted 1 and 3 for x and y into the first equation. And then the process is completed with the second equation. And as you can see, for both sides, it's balanced. So therefore, the solution is 1, 3. Now it's your turn. Work out numbers 1, 2, and 3, making sure to solve the linear systems by elimination using addition in this case. Pause it, and then once you have completed all 3, move on to the next, or push play, and you'll get the answers for 1, 2, and 3. Here are your answers. Next subtitle, we're going to use subtraction to eliminate a variable. Example 2, we're going to solve the systems of equations by elimination. So we have the equations written, and you see which is equation 1 and which is equation 2. Step 1, we are going to subtract the equations to eliminate one variable. Well, if you look over at these equations, we don't have a set of equations that are, or set of terms rather, that are inverse, that are opposite of each other. If you look here, these are the exact same term. We have positive 3y, and in the second equation we have positive 3y. Well, in order to eliminate or to get rid of that 3y, we have to make it negative 3y. In order to make that negative 3y, we have to make the entire equation negative. And we do so by, we're going to rewrite the first equation and rewrite your second equation. But in order to make it the opposite, we are going to multiply the equation by negative 1, the entire equation by negative 1. And so when you do that, you end up with, again, 4x plus 3y stays the same. But in the second equation, you end up with negative 5x minus 3y equals negative 2. We now have inverse operations here, and what's going to happen with plus 3y, negative 3y? They're going to cancel out. And from here, you can now add these two new equations that we have, and once you do, you end up with an equation where you can solve for x. And when you solve for x, you end up with negative 4. Step 3, we're now going to substitute the value that we have for x, which is negative 4. Substitute negative 4 for x in either original equation and solve for y. So we're not going to use the equation that we multiply by negative 1. We're going to use either of the original equations, the equations we started off with. So as you can see, here's the process, and it looks as though I used the first equation. I substituted x for negative 4, and then from there I simplified and solved for y. Step 4 is to check. Now it's your turn. Here's number 4. Once you have it written, pause it and see if you get the correct answer. Hopefully you got 1, 1 as the solution. The last subtitle is Arrange Like Terms. Example 3, you're going to solve the linear system, and here we have equation 1 and we have equation 2. And as you can see here, these two equations are not lined up as perfectly as example 1 and example 2's equations. So with step 1, you're going to have to rewrite equation 2 so that the like terms are arranged in columns. Right now, as you can see here, we have 8x and then 4y is underneath that. But that isn't what we want. We want to have 8x and then we want to have 3x that's right underneath 8x. And how can we go about doing that? Well, we have to rewrite this equation here so that 14 is isolated. You want to rewrite this equation so that it is in standard form. And so we do so by work out that process, and once you do, you should end up with 8x minus 4y equals negative 4, and then you have negative 3x plus 4y equals 14. Now step 2, determine if you should add or subtract. Well, we see that we have the same term 4y. And we also see that we have negative 4y and positive 4y. We have inverse terms.